Today's lesson is on section 4.5, graphing using slope-intercept form. I've been referring to this form earlier in the chapter so that it would set up for this particular section. Once we start graphing with this method, this will be probably the easiest method we know to graph as long as the equation is set up right. So far we know three different methods, or I guess we know two. We're about to learn the third method for graphing equations. We've done finding ordered pairs, where I make sure the equation is solved for y, so like y equals 2x plus 3. And then I plug in some numbers make a little table and plug in some numbers for x, like 0, 1, and 2. And I find some ordered pairs and plot those and graph the equation. We've also done method number 2, using the intercepts method. When I use the intercepts method, again, this is also an easy one, as long as the equation's set up right. Something maybe like 3x plus 4y equals 12. So as long as the equation was set up like this, I could put in 0 for x and 0 for y and find the two different intercepts and graph those 2 points. And that would be my equation, my equation graphed. Well, now today we're going to learn this last method, using slope-intercept form. And we'll notice something interesting about slope-intercept form. Again, it's a form that it won't be a new form to us. We just got to realize how to use it to graph. But we'll find that all we have to do is we don't even have to move anything around or plug any points in. We just got to pick the numbers right off the equation and go ahead and start graphing. I've kind of summed up those first two methods here also. Also remember what the first method, kind of like I mentioned up here, up at the top, here's what we want the equation to look like. Solve for y. Y all by itself, like something like y equals 2x plus 1. For the intercepts method, like I had an example up there too, I want x and y on the same side, some constant on the other. Well, for method number 3, using slope-intercept form, we want the equation to look like this as well. Y equals, and then I have some variables here, but mx plus b. Well, again, as I'll ask the class, and I want them to kind of realize, what do they notice about this form? Well, it looks just like the form for method number 1. Slope-intercept form, and that's why I started referring to it earlier in the chapter. This is slope-intercept form when I have y equals 2x plus 1. Or any kind of equation that looks like that, where it's solved for y, and then I have the variable x on the other side. These are equations that are in slope-intercept form. And so now that we've seen that form before, it won't be so new to us. Now we just got to learn how to use it. In this form of the equation, it's called slope-intercept form because the slope and the y-intercept are the two things you can pick out of this equation just by looking at it. You don't even have to move anything around or plug anything in. The slope in this equation is going to be this variable here in front of x, the coefficient of x, m. So as I'll have students write down also along with all this other stuff that's in red on this page, the slope, as we referred to last section too, slope, the variable m usually stands for slope in any kind of algebra problem. So m's the slope, and then what I'm finding here for b, as I'll kind of explain here on the next page, this is going to be the y-intercept. This is why it's called slope-intercept form. Because if I'm looking at this equation and it's in this form, those are the two things that I can pick out easily. I can just pick out the slope and the y-intercept just by looking at it. For example, if I had some kind of equation like y equals 3x plus 5, well then the slope is going to be 3 of this equation, and the y-intercept is going to be 5. And I can just pick those things out, and I'll show us in the next few pages here how to then just go right to the graph and make the graph of my equation. But it's as easy as that in terms of picking the things out if the equation's in this form. So on that previous page, I talked about how m is the slope here. If I'm looking at the equation, m is going to be the slope of my equation. B is going to be the y-intercept. Well, previously in the class, I kind of talked about how m is the coefficient of x, how that ends up being the slope. I'm going to talk a little bit more about b. Why does that end up being the y-intercept? How does that work out? I'm going to remind us of method number 2 there. How do I find the x and y-intercepts, or intercepts method? I'm going to remind us of that because I think tying it to this we'll kind of see how it, no matter what, for what equation, it's always the same for finding the y-intercept, no matter what the equation looks like. Remember back to intercepts method, what did we do? We put 0 in for x and 0 in for y once each time, and then saw what we get when we solve from there on the rest of the equation. Well, why we did this is we're finding the x and y-intercept here. When I put in 0 for x on this first one, what I'm doing is I'm finding the point that's on the y-axis here, somewhere along here, because I haven't moved left or right at all for that point. The coordinate's going to be 0 and then something like 5. So I go left to right 0, up 5. Or negative 8. Left to right 0, down 8. So it's going to be the point that's on the y-axis, which is the y-intercept. So this right here, whatever I find, is the y-intercept when I put in 0 for x. So in this particular problem, if I put 0 in for x, I get y equals 3. Okay, so that was my y-intercept. Well, here's the thing. If you think about that, if you think about putting in 0 for x in this equation, that finds my y-intercept. Well, that should work for any equation, though, shouldn't it? Because if I put 0 in for x, I'm still saying that whatever point I'm trying to find, I'm not moving left or right at all. I'm just staying right on the y-axis. So either way, whenever I put in 0 for x in any equation, no matter what it looks like, that should be the y-intercept. Think about even ordered pairs method. If I was using ordered pairs method to graph this equation, y equals 4x plus 2, when I put 0 in for x, what happens? Well, essentially the x cancels out the x term, and all that's left is y equals 2. Where's that point? On the grid here, it's 0, 2. It's right here. What do you know? It's on the y-axis. That's the y-intercept. Anytime I put 0 in for x in an equation, I'm finding the y-intercept. Well, I'm going to notice here, as I show you a few problems, I'm going to notice a pattern here. What's going to happen always when I put 0 in for x in any kind of equation? If I put 0 in for x, and that looks like slope-intercept form. If I put 0 in for x, this term will cancel out. What do I end up getting? Well, I just end up getting the number that's over here, 8. Same thing happened for the top one. When I put 0 in for x, it cancels out the 4x here, and all I get is the 2 over here. Okay. Same thing for this one. If I put 0 in for x, in this equation, y equals negative 2x minus 15. Put 0 in for x, it gets rid of this term. What's left is just negative 15. Again, just this term out here. I even have one last example to show it. If I put 0 in for x in this one, what's my y-intercept? Negative 99,999. Okay. So, as I showed up very at the top, at the beginning here, the form of this equation, we said b ends up being the y-intercept always. Well, why does that happen? Well, look at any of these problems. Whenever I put 0 in for x, it gets rid of the term with x. And then all I find is this last number here is all that's left. So y equals that last number. So the coordinate's always 0, and then whatever that number is. That's why that point, that number, always ends up being our y-intercept. So that's kind of how the equation works, which is again very slick. Because if I just look at the equation, I can tell you, well, there's the y-intercept. If I go back to that top one, again, we've talked about how the slope is the number in front of x. So the slope of this equation is going to be 4. And now we just talked about why the y-intercept ends up being the last number, 2. So I can pick off those two things very easily. Some of the practice we'll get today will just be in doing that, picking off the slope and the y-intercept in an equation in this form, just to make sure we know, okay, which one is which, and we start getting used to looking for those numbers. So like in problem number here, just like they might see on an assignment, students might see an assignment today, it'll say identify or find the slope and y-intercept of the equation. Well, if I'm looking for the slope, again, it's the coefficient of x, or that number that's right in front of x, so negative 3 in this case. And my y-intercept would be, again, if I put 0 in for that, I'll kind of backtrack here for a second, kind of like I showed on the previous page. If I put 0 in for x, it would get rid of this. So my y-intercept would be negative 5. So there would be identifying those two things. The slope would be negative 3. The y-intercept would be negative 5. In this problem number 2, same idea. My slope here, even if it's a fraction, that's okay. My slope would be negative 1/3, that fraction. And my y-intercept would be, well, I guess in this case, 5 over 2. Or 2.5 if I change that into a mixed number. But I can just leave it like that too. Okay, so there'd be identifying my slope and y-intercept in those two problems. Also, we've dealt with solving the equation for y or getting it in slope-intercept form already. So if we do all of a sudden, you know, I've worked on getting the problem into this form, what we have. So if I get a problem like number 3 here, students shouldn't be too alarmed. This problem's not in slope-intercept form, this equation. So I have to get it so it's y by itself first before I can identify the slope and y-intercept. But again, we've practiced this already, so this shouldn't be too much of a challenge, or at least too much of a thing that's, you know, unfamiliar to us. We have seen this before, so hopefully after a few problems it'll kind of ring a bell, and we'll remember how to do that. If I want to get in problem number 3, this equation, if I want to get it in slope-intercept form first, I got to start moving things away from y and get y all by itself on the left side. So if it says minus 10, I'm going to add 10 to both sides. That'll get rid of the 10s on the left side. All I have left now on the left side is y. Good, that's what I want. On the other side, I have 4x plus 10. Now I can identify the slope and y-intercept. Slope of this equation is 4. Y-intercept is 10. And this last one, number 4, to show maybe one more example here. I won't go through 5 there, I'll just go through 4. This one as well. It's not in slope-intercept form right now. So I've got to solve it and get y by itself just like we've done in the past. So then it can be in slope-intercept form, and then I can identify what the slope and y-intercept are of the equation. So to get y by itself on this one, it has negative 2y. So I would have to divide that term by negative 2. And if I divide that term, I just got to divide every single term in the equation by negative 2, and then it won't change the equation. At least it won't change the answers. It'll change what it looks like, but it'll still be a legitimate equation. Y equals, on the other side, I'm going to get 14 divided by negative 2 gives me negative 7. Negative 6 divided by negative 2 gives me positive 3x. And in this one, notice that I have the constant here and the term with x here. So they're switched around a little bit, but that still shouldn't trick me too much. My slope is always the coefficient of x, the number that's in front of that variable, x. So in this case, my slope is still 3. And also I could see this by if I put in 0 for x, it would cancel this out, correct? So that would give me my y-intercept, so my y-intercept would be negative 7. So there's my slope and y-intercept for that problem. Even though I had to solve it around and get it in slope-intercept form first, I can still do that. We've done that in the past. I can move things around and get it so I can identify the slope and y-intercept of that equation. So then just one more thing to show you about this form, or this method for graphing, which is how do you actually graph with slope-intercept form. And as I've kind of got written up here, well, once you start to get used to this form and using it, it may be the easiest method to graph with. So as long as the equation's in this form already and ready to go, all I have to do, I don't even have to plug any numbers in, don't really have to show even too much work. I just got to pick out the key numbers and use those to make the graph of my equation. Let's look at this first one. So it says graph. The equation's in slope-intercept form. It's y equals, and then everything else on the other side. So good, this is just how I want it. Knowing it's in slope-intercept form, I can pick out the slope and y-intercept right away. The slope's going to be 1/2. My y-intercept is just going to be the number at the end here, the constant, which is negative 4 because there's a subtraction sign in front of it. So there's my slope, there's my y-intercept. Well, how do I use this to graph? As I'm going to talk about in class here, we do know information about each of these two things. We've talked about intercepts. We've talked about slope. What is the y-intercept? Okay, well, as I'll kind of explain in class, this is kind of like a starting point for us because the y-intercept, if it says the y-intercept is negative 4, what is that telling me? It's telling me that the line, whatever the graph of this line looks like, it's telling me one point that it will definitely go through on this grid, and that's the y-axis. It'll go through at negative 4. That's what this is saying. The y-intercept is negative 4. So no matter what this line looks like, whether it looks like this, or this, or this, or anything, okay, no matter what it looks like, it will definitely go through that point. So that's kind of a starting point for us. So I'm going to go to the y-intercept where it's negative 4 and put a point. I know the graph of the line crosses that point right there, or it crosses the y-axis at this spot. I've used the y-intercept. Now what I encourage people to do then, once you've used it, is cross it off, because otherwise people start confusing that with the slope or get it mixed up with the slope and keep using it. So what I say is use the y-intercept and then just cross it off, because you don't need that anymore. It helped us. It did its job. Now we're done with it. Now we're on to the slope. The slope of the line. Remember, slope is rise over run. When I talk about the ratio slope, it's telling me what the measure of the steepness of this line is, like how fast it's increasing. And in particular, it's telling me how fast it goes up and then how fast it goes over in a fraction. So in this case, 1 over 2 means it goes up 1 over 2, up 1 over 2 to find more points in this line. Well, go to the y-intercept here at 0, negative 4. I know where this point is. And I know other points should follow this pattern where I go up 1 over 2. So that's what I'm going to do from the y-intercept. I'm going to go up 1 and over 2 and put another point right here. And I'm going to keep doing it to show that's where more points in the line would be. Up 1 over 2, up 1 and over 2, up 1 over 2. This is where more points on this line should be. All these points should be on the line. And then I can make a graph of it. There's the graph of that equation. I didn't have to plug any numbers in. I didn't have to solve it or anything. If it's already in slope-intercept form, I just pick off those two key numbers and use those to make a graph. Let's look at the next one here. The blue one, y equals 3x minus 1. Again, this equation's in slope-intercept form, which is nice. Y equals, and everything else is on the other side of the equation. So I don't need to move anything at all. All I need to do first is pick out the slope and the y-intercept. The slope is going to be 3. The y-intercept in this case is going to be -1. Remember, there's a subtraction sign in front means that's a negative, so -1. So good so far. Well, how did I use it the last time? Or what do I do now? Well, just like I did with the red equation, how do I graph this? Well, the y-intercept tells me kind of a starting point. It tells me one spot on the graph for sure the line goes through. And so it's on the y-axis at -1 right here. So I'm going to put a blue point right there. Again, once I've used the y-intercept, my suggestion, or once you've used it, my suggestion is just cross it off, then don't get it confused with the slope. The only thing it helps us do is kind of get a starting point, and after that, we're done with it. So I cross that off. My slope is 3. Well, remember we talked about right up here, the slope is usually a ratio, like rise over run. So it's usually some kind of fraction. Well, 3 just by itself, it doesn't look like a fraction very much, but we can write 3 as a fraction, and I'll encourage students to do this all the time in problems. If it's not a fraction already, make it a fraction just to remind yourself that you have to go up so much and over so much. Otherwise, we'll forget that part sometimes. We'll forget to do one of the two things. So how would I write 3 as a fraction? Well, it'd be 3 over 1, just like this. And now this tells me that I'm going to rise, I'm going to go up 3, and I'm going to go over 1. I'm going to do both those actions, and then put another point. So I start at my y-intercept. I know the line goes through here at -1. And then I go up 1, 2, 3, and over 1. There's going to be another point on that line. And if I do it again, up 1, 2, 3, over 1, there's another point. And I could keep going on and making more points, but that's really good enough for me to make the graph of an equation. I really only need 2 points. I just make a few to kind of show the pattern, but that's all I need right there. One more example here. This equation also, it's in slope-intercept form. It's y equals, and everything else is on the other side of the equation. So that means I can just pick off the slope and the y-intercept right now. I don't have to move anything around at all. My slope, right here, the number in front of x, the coefficient of x, which is just -2. I don't need the x with it, but just -2. My y-intercept, the number at the end here, if I put in 0 for x, everything would cancel out. I just have 5, so that's my y-intercept. So 5. Just knowing these two numbers, I can make the graph of the equation. My y-intercept is 5. So if nothing else, I don't know much about this graph yet, but I know that it goes through the point 0, 5. So I'm going to put a point right there. Then again, I like to cross the 5 off. Otherwise, some people kind of get it confused or mixed up with the slope when they keep graphing. So cross that off. I don't need that anymore. It helped me get a starting point. Now it's done. My slope, -2. Again, if your slope isn't a fraction, maybe write it as a fraction just to remind yourself it's rise over run. So I have to do 2 different directions here, and that'll remind me to make sure I do both of them. So -2 over 1. What does that mean? Well, -2, then the top means go down 2 in the y direction. So I'm going to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. That's where all the points should come from. Oops, that last one just a little off. Down 2, right 1. There's some points. There's 4 points right there. I really only need 2, but I just made a bunch to kind of show you what it looks like. There should be the graph of that line. Also, think about what we learned about slope as well, too, so far. This right here is a negative slope line. That makes, or at least I saw that it's a negative slope in my equation. What do you know? The green line is slanting down and to the right, which we talked about being a negative slope. So again, those things should make sense. The red and blue ones are positive slope lines. What do you know? They slope up and to the right. So again, all those things that we've learned already with slope even tie in. So we'll practice this more in class as well to get everybody kind of comfortable with it. But there's a few examples to show us how to graph with this method. And I think we'll find that once we learn this method, once we get used to it, it's probably going to be the easiest of the 3 methods when it's set up and ready to go.